Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Staircase Serpent by Yitrio. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have a yin-yang snake, where we need to draw a 1-cell wide snake of orthogonally connected cells that does not branch or touch itself. The non-snake cells must form a single orthogonally connected area. And no 2x2 area can be either fully snake or fully non-snake. So as an example, this could be an example of a yin-yang snake, where it's a 1-cell wide snake of orthogonally connected cells, which does not branch or touch itself. So what does it mean to be an orthogonally connected area? It means that you can go from any cell in the area to any other cell in the area just by going through edges, all while staying within the area. So for example, this works here because trying to go from here to here means you can go along this route, which means you can go all along these edges. The non-snake cells also must form an orthogonally connected area. So to get from this cell to this cell here, you can go through edges while staying within the area like this. Or like this. Either one works. And then we have no 2x2 area can be either fully snake or fully non-snake. So for example, this would not be a valid yin-yang snake because we have a 2x2 area that is fully non-snake here. And we can't have a full snake like this either because this area has a section that is fully snake. So that's how yin-yang snake works. Snake is also must be essentially, you have to be able to form a cell or a path essentially along this snake where it doesn't branch and it doesn't touch itself. So another thing about touching touching itself would be something like, say, this, I think. Because I believe that you cannot touch itself diagonally either. I don't think it works actually either way anyways, because if it touches itself diagonally, it'll necessarily have to sort of box in an area that is non-snake, which cannot be because the non-snake cell must form a single orthogonally connected area. So the snake cannot touch itself orthogonally or diagonally in this case. So this could also be valid as an orthogonally connected snake or a yin-yang snake. Anyways, the snake acts as an entropic line, where each set of 3 adjacent digits along the snake must be one low digit, 1, 2, and 3, one medium digit, which is 4, 5, and 6, and one high digit, which is 7, 8, or 9. So for example, for these 3 cells, you could have something like, say, 8, 5, and 3, and this would be valid because along these set of 3 digits along the snake, we have 1 digit which is low, 3, 1 digit which is medium, 5, 1 digit which is high, which is 8. And that's how the snake works as an entropic line. All cells connected by a white dot or black dot are on the snake. So this is not actually valid because all of these digits must be on the snake. Digits separated by a white dot are consecutive, and digits separated by a black dot have a ratio of 2 to 1, and not all possible dots are necessarily given. So for example, say this was a 6 here, this would have to be 5 or 7 here to be consecutive with it. if this were, say, 4 here, this would have to be 2, or 8 to be in a 1 to 2 ratio between them, because there's a black dot between them. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so pardon me, I got a phone call. I'll be right back. And I'm back. Sorry about that. Had a phone call I had to take. Anyways, let's get started. Did we already do that? Well, let's read. Let's learn how to Sudoku. Okay. So all cells connected by a white dot or black dot are on the snake. So these must all be on the snake. We'll mark those as, I guess we should mark it as green because, okay. So to be valid as a snake, this has to be, well, we don't have to exit out, actually. So we don't know that we're exiting out there. This cannot, well, we don't know the exit out's that way either. Okay, we do know that the snake has to be 1 low and 1 medium and 1 high for 3 unique digits along the snake. So for these digits, these have to be, can never be 1 low and 1 low, or 1 medium, or 1 high and 1 high digit. They have to be different entropic values, 1 medium and 1 low, or 1 medium and 1 high, essentially. So this cannot be 1 and 2 in the 1 to 2 ratio. So it's 2, 3, 4, 6, and 8, as are these. These are 2, 3, 4, 6, and 8, because you cannot have 1 and 2 be next to each other on this entropic line, because they would both be low. And we know both of these are on the entropic line, as are these, as are these. We know one of these must be non-entropic line. And at least, it could be both. So if this were not entropic, this would have to also, sorry, this would have to be non-snake cells. So if this is one of these two is non-snake, because otherwise, if it weren't, we'd have a 2x2 area that would be all snake, which is not allowed. So if this were non-snake, this is guaranteed to be non-snake, because the non-snake cells must all be orthogonally connected. And if this were non-snake and this were snake, this would be blocked from the rest of the non-snake cells. So this is guaranteed to be non-snake. Okay. Oh, these digits are consecutive. So it can only be 1 low and 1 medium, or 1 medium and 1 high, which would mean it's 3, 4, or it's 6, 7 here. And it's the same for all the white dots. So this must be 3, 4, 6, or 7. Okay. What does this tell us? I am not particularly certain. Okay, this has to have 2 cells that are non-snake, or 1 cell that's non-snake. It cannot be just that by itself, because then that would block, this would then be snake, and this would all block this cell from connecting orthogonally to the non-snake cells. So this has to be non-snake. It must orthogonally connect, so this must go out as a non-snake there. Same with one of these two, but this could go out either way here. So this could end here and here. Otherwise, it connects this way. It could just end here, period. We don't know. So that's the thing about snakes. It's specifically snakes. Since we don't know where it ends, we don't have any intuition about where it must stop. So, hmm. A single orthogonal connected area. Okay, this has to exit out because it must connect to the rest of the non-snake cells. Okay. Um. Can this ever connect this way? Not certain. We know one of these pairs has to be 4 with 2 or 8, and the other pair has to be 3 and 6. Because, say this was 2 and 4 here, that means this has to be 3, 6, or 8 in a 1 to 2 ratio, and obviously 3 and 6 would be there. Same with this. So, we are guaranteed 3, 4, and 6 must be next to one of these black crop key dots. Which means the rest of the box cannot contain 3, 4, or 6. So we have 1, 2, 5, 7, 8, or 9 as the rest of the box. Okay. So either it connects this way, or these are two separate segments of the snake. Okay. We have to have a snake be part of this. So if we tried connecting... Well, this could be the end of a snake. That is potentially possible. This can never enter in this way. So either it enters in... It can't be entering in this way, because that would be considered touching itself. So to enter this 2x2 area and this 2x2 area, it could go like that. Yeah, what happens if we connect that way? We would necessarily have to enter in from here. So entering in this 2x2 area can't be from here. It could be either from here or from here. Or potentially from here. can't be from this way. That would be considered touching. I I guess it could do something like that. That is also possible. It would be considered entering in from one of these spots then. Huh. Hmm. I don't know. This doesn't seem very easy to me. Maybe it's just me. So you could do something funky like that. Hmm. Um. Hmm. Can you come in this way, though, is the question, right? If you connect that way, that's... Uh, hmm. So for this either ends here or it could connect this way. So it could end that way. That is possible. It could just connect through. Hmm. This must be a different set of digits than this. So if this is 3, 4, obviously, then this has to be 6, 7. If this is 6, 7, then this would obviously be 3 and 4. Um, hmm. We have to orthogonally connect all non-snake cells, though. Okay. Um, so say we connect that way. Uh, hmm. This must orthogonally connect at least once this way. So this would end here or end here. Ugh. One of these digits is a 3, 6 pair. That's interesting. That means if this is 3 and 4, we are guaranteed one of these has to be 6 then. If this is 6 and 7, we are guaranteed one of these is 3. So 3 and 6 cannot appear anywhere else in row 2. 1, 2, 4, 5, 7, 8, 9 then for the rest of the row. But does that help? I'm not particularly certain. Hmm. One thing it can't do, obviously, is go like that. We could... So what happens if we do enter here? Then it has to do something funky like that, right? But it could just go straight down. Um... Hmm. It cannot close off, though. Huh. How does this work? The problem is it must orthogonally connect. I mean, so far this... Okay, that doesn't work. So if we try to do something like this, the problem is the non-snake cells would now not orthogonally connect, right? It would be blocked here. But I'm trying to figure out how to do this in general. Like, um, hmm, um, this doesn't seem, I don't know, this does not seem easy to me. Part of it is we don't have it, since it's a snake, we don't have any implications here. We just know it has to be, if it's on the snake, it can be connected to one cell on the snake orthogonally. But that's all we have. Oh, how would it connect here then? These would have to be the same set because every third set is on the same set. And then these would have to be the same set. So it could be 4, 6, and 3, and 2, if that's the case. So that could work. Um, huh. Um, hmm. Um, hmm. So that could work if it connects that way. That would mean this has to be a high digit, which could be any of 7, 8, or 9. If we continued on here, it would have to be a high digit, but that doesn't really help us much. Hmm. One thing is, if so, hmm, can we ever do this? I think the answer is no, right? So if we connect from here to here, if we connect from here to here and then connect from here to here, how is this going to form a snake with all of these parts? It can't without touching itself, right? It would have to go this way and then touch itself. Um, so if we could do something like that, we are guaranteed that we have to get to here from the snake and it would end there. So then that would connect that way. Or we go out this way, it would have to do something similar, right? Um, So if this goes down, it doesn't connect to here. The problem is it would have to connect this way. And eventually it would have to go down to here without essentially as a snake, because we can't have a 2x2 area that's an all non-snake. So that's if it avoids this in general. What if it goes here? It could do something, well, if it does that, it has to go like something like this. And it still would have to go here, right? So this is forcing a problem that it has to continue as a snake going there. Right. So it either connects to here or it goes straight down. I guess it could do something like this, maybe. But even that is, I mean, well, you could do something like, I guess, like this. Huh, that's problematic, because if we try to go like that, so try not connecting this way, which means nothing, there's no snake part here. So if we try to have this be essentially some weird snake part connecting here, I don't think it works. I guess technically this could be the end of a snake. I mean, it could be the end of a snake going like that. That is possible. But either way, having, what does it, can it do something like that? This feels like it's too broad to be just a very easy puzzle. The logic here doesn't seem that difficult. It's just like a matter of trying to figure out where the snake can be. Hmm. So can this be non-snake is kind of the question. We just basically do that. This has to connect a snake. This could connect a snake. This could end here. So this is done. This is one end of the snake. So the question is, can you do something funky where, like, you do like this? Maybe. Maybe? I don't know. The problem is this would be a 2x2 area. Well, I guess you could do something like this then. Well, but then this would not be orthogonally connected. Oh, right. I forgot about that. For yin-yang shading, anytime you swap colors, you can only swap twice at most. I don't think this is considered very easy. But you have a definite swap here. This is shaded, this is snake, and this is non-snake. So therefore, you can only swap at most, you can only swap 0 or 2 times of colors. And the reason why you know that is, say we swapped more than 2 times. You can't swap an odd number of colors, right? You can't swap once and then only can't swap back again, right? Or can't not swap back again here, right? You can't have this be all non-snake, swap once, and then you can't swap back, or can't not swap back, right? Because it's going to be a non-snake here, and then a snake somewhere here. So that's 2 swaps there. I don't know if that was very clear. But if you swap once, you must swap again on the other side, right? Because these are different colors. And these, eventually, this is going to be back to the other color. So that's guaranteed you have 2 swaps. So it's some amount of even swaps. And you can't have more than 2 on the edge of the grid, because say we had gray here. Well, actually, just show this. This is gray, this is gray. How do you orthogonally connect the gray without breaking up the snake? And you can't. What about if you try to orthogonally connect the snake without breaking apart the gray regions? The answer is you can't. So the reason then we know that this has to be green is we have a non-snake cells here Therefore, all of these must be snake cells. So that helps there. That means we have a 2 by 2 area that is snake. This cannot be snake, so that's non-snake. Same here, same here. This has to be snake because otherwise it would be swapping more than 2 times on the edge of the grid. This goes snake there, so this cannot be snake. That's done there. That means this can't be snake because it would be considered touching itself. Same with this. Same with these two. So this has to go out there as a snake. So we know these are two sets of the same set. So this has to be 2 and 3 with 4 and 6 here. So that eliminates 2, 3, 4, 6 in the rest of the box. This has to be a high digit. This must be a high digit then. So we know the high digits are here. So every third cell on the snake must be a high digit. So that means this one too. So every third digit is a high digit. So this is a high digit, which means these are all highs. This cannot be 3, 4, or 6. It's 7, which makes that 6. Therefore, this cannot be 6 here. We have to have a 3 here to be with a 6 here. So we know one of these two was 6 here. This cannot be 7 here because of the 6, 7 pair in the row. This can't be 7 for the same reasoning. This must connect to this side either this way or this way. This is non-snake because it has to go this way as a snake. So therefore, the rest of these are non-snakes to make sure that we don't swap more than twice on the set. This is 6, so then every third one here is an even cell, which means all of these are low cells. So we have low, 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 low. So these are all low, which means the greens are 6. This cannot be 4. It's just 2 and 3 next to 4 and 6. Therefore, this is not low. This is 4. So the 4 next to 2, which makes this 6 and 3. That eliminates 2 and 4 in the rest of the column. This is 6 and 3. We have 7, 8, and 9. This must be 1 and 2 remaining. 1 and 3. These are all high. This is a low. Cannot be 4, 5, 8, or 9. So this is low. It connects to one of these two. And that must be a high, which forces this to be medium because it's going to be the third cell. So this must be then medium, which must be next to a low. So therefore, this is medium next to a low, so that's 4 and 3, which means this can't be 3 or 4. It's 6 or 7. This is low here because every third digit must be a low. There's no 4 here. So one of these is high. We're not sure which, connecting to this. This cannot be 3 and 6 because of the 3 in the row, so this must be 8, which means it's in 1 and 2 ratio with 4. This is high. So it cannot connect this way. Because if it connected this way, then you'd have a high next to a high. So that means this has to connect here. We have to have something here in a 2 by 2 box that's non-snake, so it has to be here. So therefore this is 2 by 2, which means this cannot be, this is 8 or 9. This cannot orthogonally connect to these cells, so therefore that's blocked. Actually, no, it could go here. This one, though, is not. So this could go this way. This connects to one of these two. It cannot go here because then that would touch this cell that way. This is 6, 7 as a pair. Eight cannot be here because of 8 in the column. This can't be 8 because of 8 in the column. So this is 3 or 6, which must be in a 1 to 2 ratio with 3 or 6. But this can't be 3 because of 3 in the box. So this is 6 and this is 3, which means this is low. So it cannot connect this way. You could technically end there. Yeah, and in fact, if it goes this way, the problem is... So these cannot connect. If this tries to connect, it would necessarily have to be medium for these 3 cells. But then the problem is these 3 cells would have 2 mediums and a low, which is when we need 1 of each set. So this cannot connect. Neither can this connect. So we know one of these is the end of the snake and the other one is the end of the other snake. Okay, so this cannot connect because they would be orthogonally connected to each other, but it wouldn't be able to form a snake, so this must go this way. No orthogonal connection, no orthogonal connection would be touching. So it connects here, then connects to one of these two. So this would be medium, low, and one of these is high, which forces that medium, low, and then this would be high, and then this would be medium. So this is medium, that's 6, this is 7. This cannot connect this way because it would be orthogonally connected. It would be branching. Same with this. Okay, this is low, low. So this has to go this way. This would then be low. High is one of these, and then connecting to a medium. Then this is low. We don't know if it connects to this. This can't be part of the... These can't be part of the snake because that would be considered branching. Okay, this has to connect to here because this is one end of a snake and this is the other end. So then this must be low here, connecting to here. These cannot connect because of the same reasoning. This cannot connect here. So it's one of these two, one of these two. This is low. This must connect to one of these two. This could continue on there. These cannot be part of the snake. Three eliminates 3 here. This is 1, which makes this 2, which makes that 1. That means this can't be 1 or 3. It's 2, which forces that to be 3 there. That's 3 in the corner. We celebrate because we're nowhere close to solving this. This can't be 7 either of these places, so this is 8 and 9. This is low, so it's 1 or 2, 1 or 2, 1 or 2. We have to have a 3 somewhere in row 5. It cannot be here because of 3's in the boxes, and these are not low, so this must be 3 here. We have to have somewhere 3 in column 2. Cannot be any of these cells because of 3's in the boxes, so 3 has to be here because it can't be a medium digit. 3 can't be here or here. Therefore, one of these is 3 in column 7. This can't be 4 or 6, so that's 5, which makes that 4. This can't be 4 or 6, so that's 5. 4 can't be here, so 4 has to be one of these two. 6 cannot be here, here, or here. So 6 has to be here in this upper central box. No 6. This can't be 4 or 5 because of 4 or 5 in the row, so that's 6. Where is 6 in column 7? Can't be here because of 6 in the boxes, and these are both high, so 6 has to be there. Where is 6 in row 9 then? Cannot be here because of 6 in the boxes, so it must be there, because this can't be medium. Where is 6 in column 3? Can't be here or here because of 6 is in the boxes. This is low and high, so this must be 6 there. Actually, that's 8 sixes, so we know have all the 6s. 5 cannot be here in this lower left-hand box. Can't be here, so it must be one of these two. This is 8 or 9. Remaining digit in the column 9 is then 4. So that's 4 here. 4 in this right central box must be one of those two. And it cannot be... Where's 4 in column 7? Can't be here because of 4 in the box. Can't be here because of 4 in the row. And these are non-medium cells. So this must be 4 here. Where is 4 in row 6? Can't be here because of 4 is in the boxes. Can't be here because of 4 in the column. So it must be there. The 4 in column 8 then must be one of these two cells. This is 4, 5 as a pair. This cannot be 5 because of 5 in the box. So therefore, that guarantees this is 4, which makes that 5, which makes that 4 there. That should be all the 4s then. The 5s. Remaining digits in column 7. We have no 1, 2 because of the 1, 2 pair. No 4, 6, and 7. So it's 3, 5, 8, and 9 remaining. This cannot be 3, 5, or 8 here because of 3, 5, 8 in the row. So this is 9, which means this cannot be 9 here or here. 9 eliminates 9 here, so that's 8, which makes that 9, which makes that 8. 8 eliminates 8 in the rest of the column. This must be going from a low to a high digit, and neither of these are high. So this has to go this way, which forces that to be high, which means this is 8, 9 as a pair, which eliminates 8 and 9 in the rest of the row. So this goes high here. This cannot be on the snake then. This must go high, low, medium, low, and then high, medium, low. So that could be the high. We don't know. High, medium, low. It could be high here. Remaining digits in row 4 are 1, 2, and 7, but this cannot be 1, 2 because of the 1, 2 pair in the box. So this is 7. This can't be 1 because of 1 in the box. So that's 2, which makes that 1. Remaining digit in this right central box is a 5. Okay. Remaining digits in this lower left-hand box are 1 and 2. And this can't be 2 because of 2 in the row, so this is 1, this is 2. This can't be 1 or 2 because of 1 in the column and 2 in the box, so this is 3 because it must be a low. That eliminates 3 from being here. Where is the 3 in column 2 again? It can only be here now, which eliminates 5 from being there. So now 5 has to be here in this row. That means remaining digits in this lower left-hand box are 7, 8, 9. This can't be 7 or 8. That's 9. That makes this This has to be 8 because it can't be 7 because of 7 in the row. So this is 7 here. That makes this 9, which makes this 8, which makes that 9. 1 and 5 eliminate 1 and 5 here. So that's 2, which makes this 1, which makes that 5. 1 eliminates 1 here, so that's 2, which makes that 1, which makes that 2. No more 5 in the rest of this upper left-hand box. 8 can't be here because of 8 in the column. Okay, this is low. And we know there's a 1 guaranteed here in this upper left-hand box. So this cannot be 1, cannot be 2. It must be 3. So if this could be medium, low, high, does work. And we know this 2x2 area is non-snake, so this must be snake. And therefore this is high. It must connect this way. It cannot touch itself, so it can't be there. So therefore it must connect that way. Since it connects this way, it cannot connect here. It cannot touch itself here. So this is non-snake, which means this is the high here. So this is high here. This must connect this way. Where is 1 in this lower central box? Cannot be here because of 1 in the row, so 1 has to be here. That leaves the remaining digits here as 7 and 8. This can't be 8 because of 8 in the column, so that's 7, which makes that 8. 7 eliminates 7 here. Where is 8 in this box? It has to be here, so this is 8, which makes this 9. Remaining digit in this left central box is 7, which eliminates 7 here, so it's 9, which eliminates 7 and 9 here. It's 1, which means this can't be 1 or 9. This is 7. 3 eliminates 3 here, so it's 5 and 3. This is a high digit. We know this is 7, 8 as a pair. This cannot be 8 because of 8 in the column. So this is 7, which makes that 8 there. Remaining digits of row 5, we have 2, 5, and 9. This cannot be 2 or 9 because of 2 and 9 in the column, so it's 5. This can't be 2 or 5, so that makes this 9, which makes that 2. That leaves the remaining digit in column 4 as a 5, the remaining digit in column 5 as a 7, and the remaining digit in column 6 as a 1, which leaves the remaining digit in row 1 as an 8, and therefore this is a 9 here. Yeah, I wouldn't classify this as very easy. The logic is fine. I don't know. I feel like this is easy level, not very easy. You could even potentially make an argument for challenging, but if you, well, this is definitely not very easy. You have to know a decent amount about yin-yang and snakes and entropic lines to sort of understand how this works. The logic behind it isn't too bad, but there's a lot of assumptions to make, particularly if you wanted to. It's definitely not very easy. I'm just trying to figure out if it's easy or challenging. I mean, for me, it's easy, but I've done a decent amount of yin-yang shading and snakes and, all of the entropic lines. So for me, I can easily figure out what these were. But yeah, I don't know if I'm a good way to judge this, right? Because I've done quite a bit of yin yang shading and quite a bit of entropic lines and quite a bit of not even that many snakes. And this was a little bit challenging, I felt. Except, I guess, the yin-yang shading did make things much clearer. I think I would even put this at challenging. I don't think it's something that anybody who doesn't have a very broad experience with yin-yang shading could necessarily do. So I think I would put this as challenging. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.